Hi guys, welcome to my CSEC lecture on logic gates. And logic gates is a basic component to all electronic circuits, and it works under the binary code of 0 and 1. Now in this lecture we're going to examine all of the different types of logic gates and their truth tables. Now the truth tables basically indicate the behavior of the gate when they are connected to their electronic circuits. So for example, the first gate I am seeing here is an inverter gate, right? So the purpose of the inverter gate or the NOT gate is that it inverts whatever signal is applied to it. So this, if you notice here, you would have had this symbol here, which is that for the inverter. Now if you look here, A is the input and B is the output. So A goes from 0 to 1, and that's inverting it, and B goes from and you can also have another input, from 1 to 0. The other type of gate is called the OR gate. Now stemming from the NOT gate is the only it's the only gate that has a single input, right? But if we look here at the OR gate, right? So if we look at the OR gate now, the OR gate is what we call a dual input. So it means basically that you have two inputs, A and B. Now, if you have more than two, for example, you could be able to predict the number of output combinations. That is the number of input combinations you can have with 0 or 1. And that will tell you how many possible outputs you can have. So we could use this little formula here, 2 to the n, where n is the number of inputs. So if I have 2 inputs, then I can have 2 squared, which is 4 possible outputs. Now typically, you're looking at a combination when you have 4 outputs. You're looking at a combination of 0, 0, 0, 1, 1, 0, 1, 1. Now, needless to say, if you have, let's say, I have 3 inputs, for example, right? So that would have been 2 to the 3, which would have been 8 possible outputs, okay? All right, so in any case, let's look at the OR gate, right? So this gate functions as addition. That is, once you have a 1 present in the input, the output is 1. So the only time we have 0 here is when there are no 1s. Conversely, the AND gate functions as multiplication. So here, again, I have dual inputs A and B and an output C. Once you have a 1, that is 2 1s present, only then can you have the output being 1. Other than that, the output is 0. Now, the NOR gate is also called NOT an OR gate. So because I have this inverter symbol here, it shows that I am negating the output of an OR gate, right? So previously in an OR gate, you would have had, once you had a 1, your output is 1, right? But in a NOR gate, now when you have a 1, your output is 0. So only when I had no 1s, I would have had an output of 0, which is now 1. In a NAND gate, it's the same thing. Once I have this circle here, it is representing an inverter. So what you would notice is that it's where I would have had in an AND gate 0, 0, 0, 1. Now I have 1, 1, 1, 0. So it's inverting my signal of an AND. So now if I have 1 and 1, in an AND gate I would have gotten 1. But in a NAND gate it would be 0. Now an XOR is called an exclusive OR gate, and it's different to the OR and the NOR because of this bracket here. Now exclusive OR simply means that either of the inputs have to be different for your output to be 1. Once you have your inputs being the same, your output is 0. So if now I had an XOR and I add an inverter to it, then this would give me an XNOR. Now your XNOR, if I go back to this combination, your XNOR will only give me 1 when both of my inputs are the same. Now, this is an example of a typical combinational circuit. And a combinational circuit is one where you have different gates being attached in a certain arrangement, and based on the inputs, you have a output, right? But that output is only dependent on what inputs are used at the time. So here, the first thing I teach my students to do is that you are asked to get the output to each gate. I typically tell them use any letter and indicate it in your column. Sometimes they give you it in a circuit, that is, they identify the output to each specific logic gate. The next step goes into identifying the type of logic gate. So clearly, this here represents a NOT, and this here represents an AND gate. So once you've identified the type of gates, then it's very easy to now plug in your values once you know the behavior of those gates. So here, X is not A. So if I look at my column, 0, so that goes 1, 0, 1, 1, 0, 0, 1, 0. Now, if I look here, it is X and B that go to the AND gate. So I'm looking at X and B column. So in an AND, I'm only getting 1 if both of my inputs are 1, which would be in this case here. Okay. Now, one of the things I just wanted to show you is, let me just say that I had 3 combinations, A, B, and C. So if I have 3 different inputs, right, I would have had 2 to the 3, which is 8 possible combinations. Now, teachers teach it in different ways, but I found one of the easiest way to use your truth table is you start off with 4 zeros here and then 4 ones, right? And then you hit them 2 zeros, 2 ones, 2 zeros, 2 ones. And then you hit them 0, 1, 0, 1, 0, 1, 0, 1. And then that is the easiest way to conceptualize 8 different inputs. I hope that you have found that this video is useful. Stay tuned for other videos.